itself, but in general, this has been very much needed in enterprise applications like Oracle, where several suites of applications exist. For example, if you're talking of the Oracle Marketing Cloud or the Salesforce Marketing Cloud or the Adobe Marketing Cloud, lot of these applications or products in the suite have similar needs of models, except the data is different, the input is different, but the model code is 90% same and 10% needs to be tweaked. So this 10% of difference in the model code is what we are porting, and we found the need to do this efficiently. And the innovation is not, it's not transfer learning, it's not full transfer as well, but we call it lift and shift of model code. We found it's arises especially in enterprise software where we need to have easy to do machine learning um, uh, frameworks, as well as is lift and shift of ML model code in similar needs in different domains or in different applications in the suite. So what the study proposes over the past 4 years is we designed an architecture where we have a microservice to serve the ML logic itself, to serve the ML models in the entire system of the application. So we are serving the ML model, and we are serving the ML model code in different applications by tweaking it using so-called data tuning layer um, with respect to and data porting layer with respect to the models. So we have tried 3 different layers of porting, and our experience has been that um, as the complexity of the porting increases, as the technology improved, we get more and more better and faster and quicker innovation. And why are we doing this? The reason we are doing this is to innovate quickly. The whole purpose is build once, reuse several times. Well, that's true for transfer learning, but it's true for transfer learning only if the data inputs are the same. But who can guarantee that across domains you have exactly the same data inputs to the model? That is not a guarantee. It's very much possible that maybe there are a little bit slightly different inputs. So why don't we easily and innovatively tweak the model code itself to adjust for that? Is the whole study or the PhD. So the research question is, how can you accelerate innovation? And we are talking of not only just accelerating innovation, right? We are talking of development of the code itself in the new domain or the new suite or the new application of the suite. So development of the code, the deployment of this code, the models code in the new suite. We're talking of portability of the model code. And also, we have built a framework called Minerva, and this is proprietary. But then we rebuilt a little bit part of the stack in a next generation framework called Contain in my lab in Sirius Mindshare, which is available as open source. So this framework forms the foundation of the microservice around which the data layer is structured next, and then the model code porting happens. So these were the research questions which we chased for, and we achieved most of them. Um, and the study involves um, how much gain in development speed did we get? How much gain did we get in deployment speeds? Were we able to port? Can we port across domains? And is this microservice that was designed, is it scalable? Can it handle um, how many requests per second and so on? So we designed something called Minerva or Contain. Contain is the next generation open source miniature version of Minerva, redeveloped to make it open source, whereas Minerva was proprietary to Oracle. So in general, the differences with the existing frameworks out there, the main difference is they do not support porting of model code across domains. So they do not support this. And most of them also do not support backward compatibility with on-premise. So if you think of on-premise, on-premise is something which is very um, largely existent in the cloud, in the edge networks. So if you see edge devices, they are pretty much the framework of ML happens on the device itself or on premise. Uh, so um, so on premise backward compatibility of our framework along with port capability to port across multiple domains of the model code is the uniqueness of this new framework that was designed and enhanced with a data layer. And most of the experimentation happens in the data layer to see which kind of structures of low code, no code, and high code um, can be ported quickly. So the research method has been to study with and without microservices what is the speed up of the development activity, porting of the model code itself with and without the data layer, how does it speed up, and what is the request per second of this framework. We mostly used proprietary data sets, including some public data sets which are available in our open source GitHub. Um, and the logic has been to use real world use cases, data sets to experiment. Um, and So that's the main, there was no synthetic data created. Some data sets are small, which were used for evaluation purposes. Some are large, proprietary, which cannot be released out. So these are all ablation studies. Ablation means with and without. So with and without the microservice, our framework Minerva contain, what is the speed up in development activity? Then the next one is with our microservice, with and without the data layer, and there are three data layers that we design. What is the speed of development activity, or also what is the speed of the porting activity? And also we do our experiments in multi-context. For example, we did not limit ourselves to just the Oracle Marketing Suite. We experimented beyond that to other whether the porting happens across domains to other products. For example, if you take from a product called MailChimp software and build a model there, can we port it to constant contact, which is another application which is used for marketing? Can we port it like that, etc.? These multi-context multi enterprise software studies have also been done, so that the methodology is not limited to one company's products, but you can also port it across generic uh, uh, mechanisms and products. And finally, we do a bombard our framework with repeated tests to see how many requests per second can it handle. So at the bottom of this, generally in an application, um, if you think of applications like Oracle applications or SAPs or Salesforce or Adobe's marketing clouds or other clouds or a lot of the enterprise software, including ServiceNow, all of them will be something similar. All of them are built on legacy technology stacks. Legacy means they arise from non-cloud, then they became cloud, transform themselves to cloud applications, and eventually they are now adding AI into their, or most of them have already added AI into their applications. These AI features are all available when you use the products. So in order to accommodate such, AI ingestion into these enterprise software, we devised, and also to quickly innovate. The bottom layer is the Minerva or the contain layer, which is divided into three layers. One is the app layer or the various models. Then there is a interface layer, and then there is a core layer which provides core services. These three layers are designed in the framework at the bottom as a microservice, which can then be plugged into the overall ecosystem of these enterprise applications. And these enterprise applications generally process data in the middle layer, and surface UI at the top layer, sitting on top of some massive databases, and some shared spaces, and orchestrating all of that in some logic, and business logic, sitting in some middleware. So the generic framework that we came up with has a core layer which produces things like multiprocessing, connectivity, batch training, batch prediction, online prediction, including things like security logging, configuration, all of this in a Dockerized framework. The middle layer is about versioning of the model, storing of the models, exceptional handling, and things like that. And finally, the top layer is the ML model code, or the ML models, which run on any kind of third-party libraries, whether it be TensorFlow or scikit-learn or anything like that. And so far, this is a single node solution. It is meant for edge devices. Specifically, edge devices is a use case for this framework. But there could be with the help of Kubernetes, since it's a Dockerized solution, it could be scaled up in an enterprise cloud offering as well, using all the various cloud containers management systems like EKS and things like that, in Amazon or in Google Cloud or in Oracle Cloud and so on. So it's a generic framework itself. Minerva is proprietary, but the sub framework called Contain, which is available in our open source GitHub, a miniature version of it is available for free to be developed further by your needs. So the first layer that was designed was the microservice layer, right? So it's a microservice. So obviously, the model data inputs are being sent to it via JSON. That is what is shown here, and the data schemas are. So in this, we pass on the schemas of the data and the storage results, location, and some other parameters, database locations, etc., to the microservice. So that is the high code. This is the high code in the sense that when you high code, we have divided the data layer into three pieces. One is high code, one is low code, and one is no code. High code means when somebody is porting, they pretty much rewrite the whole code again to port it. So that is high code. Now, we devised another kind of like a data layer on top of that microservice to port just by using configurations and adjusting the data input differences into the model in some way. So that was done through JSON, and this is some kind of no code layer in the sense that if the model in the new domain, the inputs are only slightly different, the model is pretty much the same, then we can use some kind of no code solution, configuration solution to map the new domain's data into the model itself. And so that is the no code solution that we came up with, where it's just through configuration and no code is written. So in this case, and finally, there is a low code solution where the code itself is being rewritten to tune to the new data inputs through ChatGPT's fine-tuned data copilots, data querying, data code copilots. We use these copilots to adjust the code of the model itself to slightly to port and adjust for the new domain through ChatGPT or generative AI copilot mechanism. So this is the low code because some code is being written, whereas in the configuration mechanism, no code has been written. And in the static mechanism, high code, the entire code is being rewritten. So how is the so that is the architecture piece, and the three layers or three types of layers which help porting of code. But our experimentation is in speed of innovation, right? So this is a study of speed of innovation because that was the business goal. So the speed of innovation is studied by actually asking developers with a specific profile to port code of certain kind into a new domain. So this is actually an experimentation happening in real time where somebody is being asked to say, take this and port it with this profile. Mostly the profile is 1 or 2 years of software engineering experience and data science experience. An engineer will be given the task and asked to port. So we found that for high code solution, just by introducing microservices, the porting is super fast, or it is a 2x performance improvement. And the deployment is pretty much the same time. There is no difference in the deployment because the deployment is and does not involve code rewriting or anything. It's the same set of activities, so there's no difference. In the no-code solution, and we are going in a tiered fashion. Right? The reason we call it tier is because this is how the evolution of the technologies evolved over the past 4 years. So on top of the microservice improvement, if we want to port using no code solution, does it give a benefit? We did not see that much of a code. So using this configs and JSON configs, and if somebody the engineer tried to port it, they did not see a bigger difference because microservice already absorbed the layer. Design one already absorbed most of the improvement. There was a 2x improvement, but not so much, which rather it's not statistically significant. And the final experimentation is in terms of uh, mm, the contexture. So we actually experimented with different contexts and we saw similar lifts when not just limiting to one kind of enterprise software. And the final experiment is in generative AI. The generative AI, if you already have improved your speed of development activity through low configs, through configs, and then if you add on a generative AI layer and say now do the job and compare it to the no code solution, there is not a significant improvement. But there is a significant improvement. There is a significant improvement in generative AI based porting if you had not already improved it. I'm going in a tiered fashion saying that can you get more gain? Can you get more gain? Can you get more gain? So generative AI will not get you more gain if you have already improved it, which is what all these companies have been doing, right? They have been not sitting idle. Most of them have been improving their products with various mechanisms. But if you're starting from scratch, generative AI will be giving you a big lift in terms of porting of this model code. And our framework, Minerva, or the subsequent framework Contain, is available in public domain. It is capable of 10 requests per second capabilities, which is near real-time capabilities, especially if you're looking for edge device solutions. This is super useful. So in conclusion, the microservices are essential. Well, there are several enterprise companies out there that can really benefit by using microservices. In fact, I had given this talk 4 years ago around in Santa Clara when Dr. Murthy was already there. In Santa Clara, I had given that talk. But then we went on and kept on improving our architecture. And the speed of innovation with all these various tiers of data tiers that we are designing or porting tiers that we are designing helped innovation by 2x is what we find. And finally, And this porting of code is an encouraging mechanism because, as I said, you need not, because with generative AI, you can rewrite the code now fairly easily and not just live only up to transfer learning, but also transfer the code itself as well. Thank you. And that's my talk. And I'll open for